Hello, this is the Big Data Containers final demo. I'm Sami Shahin, and my teammates are David Gomez, Keval Khara, Conrad Liu, and Hongtao Zhao, or as we call him, Brutto. So the goal of our project was to connect Dataverse to OpenShift using the Open Service Broker specification, and to use that connection in an Apache Spark cluster for processing big data job. The significance of our project is that we're providing an implementation for Open Service Broker for Dataverse, which provides a streamlined way for OpenShift applications to connect to Dataverse servers. So a background for some of the platforms and tools we're talking about here. OpenShift is a variant of Kubernetes by Red Hat. It's a container orchestration platform that helps to maintain, build, deploy, manage, promote applications. It helps you manage your containers in a unified platform. The Open Service Broker specification allows your applications to provision and bind to anything. It's attempting to replace the old method of connecting to services, which was very tedious and too invasive. Dataverse is an open source dataset hosting and sharing platform, which makes it easy to share data and credit authors. Apache Spark is a cluster computing framework for processing big data jobs. The goal of our project is to connect Dataverse to OpenShift via the Open Service Broker specification, and to utilize that connection in a sample big data application using Apache Spark. So first, I'm going to log into the Engage1 cluster on the MOC. We're using the Engage1 cluster rather than the Kaizen cluster because the Kaizen cluster doesn't have cluster service broker resources enabled by default, but the Engage1 cluster does. So our mentors helped us to set that up and give us accounts on this cluster. So this brings us to the service catalog. You might notice some green service vortexes appearing in the catalog. These are the Dataverse services that are provided by our broker. To narrow it down to just our services, I'm going to search for Dataverse, and here we see that there are 14 services provided by our broker. So this brings us to the service catalog. So we're going to provision a service of the Massachusetts Open Cloud Dataverse. Here on the information page, we see a brief description for the Dataverse service we're about to provision. So on the configuration page, you can choose which project you want to add your service to. So I'm going to add it to my project. And it gives you the option to enter your credentials in the form of an API key from your Dataverse account. I'm going to leave this blank. Publicly available datasets will be accessible from the secret. I'm going to create a secret in my project now, and so that way I can save a step of making it later. And click on create, and it takes a couple seconds and it creates your secret in your project. So here you can reveal the secret. The coordinates are a URL to the Dataverse service, and the credentials would be the API key that you entered in step 2. Now I'm going to log in through the command line. So now we're going to start up a sample application to use this secret that we created here. To do that, I'm going to show the GitHub for the sample application that we created and follow the steps listed in the quick start. So we already did step 1, and we're inside of the project, my project. So that's completed. Now we're going to create the template that's provided by Rat Analytics. So this includes some templates that aid in the creation of source-to-image applications that use Spark clusters on OpenShift. So I'm going to launch the Spark application by typing in this command. And so that command creates the application using the templates that we loaded in earlier. And so it prompts me here to expose the route. And so you need to make sure that your application has an external route so that you can view it in the browser. So going back to our secret, we're going to add this secret to our PySpark application in the form of environment variables. So this will allow the application to see the URL and the credentials that you entered in earlier. Now that we added the secret to our application, it's good to check on how it's progressing to see if the pod's ready. And so it looks like our pod's ready, and it's called PySpark 2 SSDW7. So we're going to put the logs in the terminal so that we can follow along and debug in case something goes wrong. But we can also use it to check progress on the application as well. So looks like it's up and ready. So I'm going to click the route, and it'll bring us to the sample application. So the application lists the files that are on the Dataverse that we connected to. In this case, the Mass Open Clouds Dataverse server. And so we can navigate through the files, page by page, and we can select whichever file we want to run word count through. So I'm going to skip to page 29 because I know that's where our file is listed. So I'm going to start word count. Unfortunately, most of the files on the Mass Open Clouds Dataverse are harvested from other servers, so the data access API doesn't quite work on those. So we had to upload our own data set onto the server so that we could demo this project and show that our application works on the MOC. So here we see the result of the Spark application. And we can see that there's two me's. It's an ipsum lorem text file, so there's a lot of Latin words, but we get the count of each of the words. And so you can also see the result in the terminal. And if you choose, you can go back to the file select and select a different file to run word count on. So as you can see, there are 14 Dataverse services that you can connect to. So I'm just going to select this one. And so you can see that all the Dataverse services have a slightly different description to reflect what types of data sets might be available or what the purpose of the data set is. If no description was provided in the Dataverse, we have a default one. And so you can add it to any project, but I'm just going to add it to my project again. And so the way the broker works is that if you enter credentials here, so let's say I say this is my credentials, it actually checks it against the server that you're trying to connect to see if your credentials are valid. So my credentials is probably not a valid API token, but let's just say that maybe I entered it in wrong, or maybe I'm trying to access files that aren't mine. Anyway, and so we're going to create the secret now so we can see it fail quick. Yeah, and the description says bad API key, my credentials. So it wasn't able to provision the secret so that we can connect to this service because our credentials are incorrect. So it's been tested that if you use proper credentials, the connection works. And so I have all these different Dataverse services, and if I were to connect these to the sample app, you'd see different files listed. And yeah, so the Dataverse broker is hosted in the project over here, and so I can show the logs for it. And I can switch to this project and show the logs for it. So every time the service catalog requests services, it's going to query the broker and ask for which services it provides. So if I were to click on the Splish Splash Dataverse and add it to my project and create the secret, we can see that when I click create, it's going to go through several steps in order to create that secret. So it's going to be able to provision, it's going to bind it, and it's going to return the result. And so you'll see that here in the logs. So there's a request, response, and so the bind response is here. So it is kind of like a bunch of nonsense, but it just goes to show that it is working as expected, and that it is communicating with the OpenShift Service Catalog API. So here we see a properly provisioned service. Some of the tools we used in our project include Golang, OpenShift, Docker, RAD Analytics IO, which includes the templates for Spark clusters on OpenShift, and the Dataverse API. Plus, we learned all of this from scratch. None of our teammates had any experience with Kubernetes, cloud computing prior to this project. Some of the accomplishments we're really proud of include implementing the broker logic on our own, creating a sample application without much prior knowledge on Flask or Spark, and becoming more familiar with OpenShift and in general deploying apps onto a cloud service. Some of the things we learned working on this project is to ask lots of questions. There was a point where our mentors had all the answers, but we just didn't know how to ask the right questions. And that problem could have been solved if we just asked with what little information we had at the time in order to just break that boundary. We also learned that it takes a lot of RAM for a Spark cluster to run. Also, it's helpful to research what other people have done and start from there. So in our case, deploying a Spark cluster to OpenShift is no simple task. And it's great that we were able to find the RAD Analytics Oshinko project that had already implemented a Spark cluster on an OpenShift platform. Also, we learned how to use GitHub in a more professional manner, such as opening issue tickets, creating pull requests, and using Gist. For our future work, we considered processing big data from Dataverse on OpenShift, such as data sets in the gigabytes of size. And for this, you need to add storage as a part of the sample application for big data, as mentioned by the professors. The sample app is limited in other ways as well, since word count only works on plain text, but there's other forms of data on Dataverse, such as PDF and tables, that this application doesn't really work with. The application can only connect to one Dataverse per deployment. So if you wanted to connect to different Dataverse services, then you need to have a separate PySpark application, a separate Spark cluster for that application. Also, the sample app cannot access harvested datasets from Dataverses. So the MOC's Dataverse, most of its data is actually harvested from other servers. And this creates a problem for the data access API that our sample application relies on. So we can only access datasets that are hosted on the Dataverse that you're connected to. Some of the broker limitations include there's no way to add more Dataverse services to the broker without relaunching it, since all of the Dataverse services are provided in config files inside of its pod. Another limitation is that the user needs to manually add their credentials to the service that they're provisioning via the OpenShift console. That is all, folks. Thank you for a great semester, and also thanks to our mentors at Red Hat, Dan McPherson and Paul Morie. Also, a lot of other people helped us along the way, including Sean Hurley, Rob Barron, and all the professors. So thank you very much.